Hello guys, this is Kudo, and today in this video I will show you the third method on how you can check if a game object is inside your camera by using mathematical approach. So in this video I will show you how you can do this. I will not explain all the mathematics because it's very complex. It's not that interesting, but I will still try to let you know how this thing works, and let's get into it. So first thing we need to do, so we need to create a script. So let's create another script. So let's create a C# script and let's name it. So check item visible by camera. So camera, and we'll make it math approach. And let's open it in Visual Studio. Okay, so now what we need to do, so we need to serialize some fields, so serialize some field, and let's add the private camera, so we need the camera, so let's name it main camera, all right. What we need to do, we need to add another serialized field, so this one, I will use a game object, but basically you don't need the game object to have a box collider to see if it's in the camera or not. So let's add a game object. You just need its position, so game object, and let's name it object to check. All right, so next thing you will need to have, so I will have like a lot of vector and a lot of game object to be able to see what is going on. So let's add a private, so I will add game object and I will add A, B, C, C, D, E. So this will represent all my vertex in the pyramid, and I will show you just after. But don't worry, it's very easy and very simple. So after that, what I will need to do, I will need to create some private vector 3. So private vector 3, and this vector will represent my normal vector, my different normal vector from surface plane of my pyramid. But don't worry, I will explain just after. So what I will need to have, it's a normal vector plane from the plane ABC, and I will do the same, so vector plane, and I will do the same for the other one. So ABC, after I will need ACD, after I will need ADE, all right. Next one, I will need A, B, E, and I will also need a last one, so B, C, D, so the basic of my pyramid. Oops. B, C, D, all right. And what I will need to have, I will need to have some other vectors. So let's create some other vectors, so private, and let's create a vector 3, and these two other vector 3 will be basically the director vector for the side plane, and the other one will be the director, so director of the vector, the vector director of my base plane. Okay, and don't worry, I will explain just after what everything is meaning. So after that, I will need to create some function to be able to spawn our basically points, so A, B, C, D, E. So let's create some function. So let's create a private void set pyramid point. So why I am using the pyramid point? Basically, it's because if I head back to Unity, and I already explained it in the previous video, the main camera over there can be associated with the pyramid, and the ABC point will be representing, so this will be the point A, this will be B, C, D, and the point E will be there. And with the vector director and the normal vector from all the surfaces, I will be able to calculate if the point is inside this pyramid. This is something very, on the paper is very easy, but the mathematics is a little bit hard to understand, but it's okay because I'm done it for you. I will done it for you, so don't worry. You can just use my code, and it will be very nice. So the first thing I will need to have in this set pyramid point, I will need a float. So let's call it visible height. So basically, this will corresponding to my visible height of my camera, and this will be equal. So matf, so dot tangent, and it will take 0.5 multiply by so the main camera dot field of view multiply by matf, so matf dot deg to rad, because the tangent using radiant, and this will be multiplied by the main camera dot forclip plane multiply by 2. Okay, this will be for the visible height, and let's make the same for the float visible width. It will be equal to, so same, matf dot tangent and 0.5 f multiply by the main camera, again, main camera dot field of view, again, multiply by matf dot degree to radiant, and this one will be multiplied by the main camera, so main camera dot again forclip multiply by 2, and multiply by the aspect of the camera, so main camera dot aspect, and this will give me the visible height. So tell me in the commentary if you want me to explain all the mathematics behind. I can, but I will not do it in this video because the video will be too long, and I don't want to waste your time. So just trust me for the mathematical approach, and you will see everything will work fine. So now let's spawn our A vertex. So A will be equal to GameObject. So GameObject dot will create a primitive. So GameObject dot create primitive, and I will create a primitive GameObject of type sphere. All right, like this, and A dot name. So let's name it. Basically A. Something very simple, and let's change its position. So A dot transform dot position will be equal to my main camera dot transform dot position, and the parent, so A dot transform dot parent will be equal to main camera dot transform. So why I am doing this is because if you move your camera or if you rotate the camera, the A point will also always follow the camera, and I got this advantage of not recalculate the coordinate of the point of the A, B, C, D, E point if the camera is moving. So this is very nice. And last thing I want to do is to make the sphere bigger. So A dot transform dot local scale. Oops, not local earlier, but dot local scale will be equal to vector 3 dot 1 multiply by 20. So like this I can visualize very nicely, and this will be the A point. So if I show you, the A point will be over there. So this will be the A point, this will be the B point, C point, D point, and E point. So now let's create the other point. So A, so now let's create a B point. So B, so let me copy paste this like that. Okay, and let's change the B point. All right, okay, B up, B, no, not battery, B, okay. And what I will need to change, so the name, of course. I will need to set his parent. Okay, it's already there, like this. And what I will need to do, yeah, I will need to change his position. So be the transform not dot position but dot local position. So local position. So why I got two different from A to B? It's because the A, if I head back to Unity, A represent my pivot point of the camera. So if I move the camera, or if I rotate the camera, my camera will always rotate on the A position. So this is why the A and the B is not the same, but at the end it will be the same because will be the child of the game object. So I will say b dot transform dot local position will be equal. So I will need to create a new vector. So new vector 3, and this one I will use visible width. So visible width divide by 2, and in y, so visible height also divide by 2, and divide by 2, and the z part will be so main camera dot for clip plane. Something very easy. So this will be the B point, and I will do the same for the C point. So let's copy paste this. Okay, let me copy this, paste, 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 and paste, and also paste. And for the visible here, so for the vector, I will add minus over there, and that will be it, because it's the opposite of my B point on the axis over there. So the minus will be there. All right. So let's head back to Visual Studio, and what I will need to do, so C, I will do the same for the D point. All right, so paste, 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 and what I will need to change is the D point. I will just need to add another minus over there, and that should do the trick. And the last point I will need to add is the E point. So let me copy paste this, and if everything is working, I should be able to basically see all the points on the camera. And what I will need just to remove the visible height over there. So now let's save this, and let's call this function in the start function to see how this thing works. Okay, let's save this, and let's head back to Unity. And as you can see, if I hit play, and if I'm not wrong, so let's see the main camera, and for sure do not forget to add basically the script, because it will not work, obviously. Let's just drag and drop our main camera and the object I want to see. Right now we don't need it because we don't code anything, we just want to spawn the pyramid point. And now let's hit play to see how this thing works. Alright, so as you can see in my main camera, I spawn all the sphere. Alright, and as you can see, all the sphere represent a corner of my camera. So even if I change the rotation of my camera, or even something like that, or even if I move it, as you can see, all the corner of my camera is still good. And even so, let's remove play, and even if I move the camera over there, and I just rotate it before the start, don't worry, the point will be nicely put it in the camera. So let's check it. And as you can see, all the point is nicely positioned. Alright, so now let's reset it. So the first step is done. Now let's head back to Visual Studio, and this is now how the sink is getting dirty, because it's it's easy to understand, but I know for some people it will be more difficult to understand how to represent it in the mind. So this is why, tell me in the commentary if you want me to make a video, explicative video, mathematically approach to understand how this thing works. So what I will need to do, so I will need to make a private void set normal vector for each plane. So basically for each plane, plane, okay. So basically the plane, if I summarize very quickly if I head back to Unity, so basically you got the main camera over there, and as you can see, each face is representing by 3 points. So you got the A, B, C, this representing a face. You got the A, C, D, this representing another face. You got the A, D, E, this representing another face. You got the A, B, E, this representing another face, and the last face will be represented by B, C, D. Because to be able to define a plane or a face, depending how you call that, you just only need 3 points. And to be able to define a normal vector, what I will need to do, I will need to do some mathematical things. So now let's head back to Visual Studio. So I will set the normal vector for each plane, all the plane I show you. So let's start with the ABC plane. So the ABC plane will be equal to vector 3 dot cross. So I don't know how you call that in English, but this is a vectorial product, if I translate well in French. And basically you just multiply two vectors together. So the vector you want to multiply over there will be, so b dot transform dot position, no, dot transform dot position minus a dot transform dot position, and you want to multiply this vector, because a vector can be defined by subtract 2 points in a space, and you want to multiply this one. So let me just add a parenthesis, and you want to multiply this by c dot transform dot position minus a dot transform dot position. Okay, like this, and let's add some parentheses over there. And be careful, just make the same calcul as me, because sometimes it's matter for the next part of the code. So now let me copy paste this, okay, and this one will be not ABC but ACD, so ACD, okay, and I want to change the A vector will be the same for all the faces, because all the faces over there has common point for A, so this is very nice. So the first one over there will be C point, and this one will be D point. Okay, now let's again copy paste this vector. Let's change change the faces, so not ACD but ADE. Let's change some letters, so this will be D minus A and E minus A. Okay, again let's paste another faces, so it will be not ADE but ABE, okay, ABE, and let's change some letters, so this one will be E, and the other one will be B, and the last one, so let's copy paste this one, okay, and this will be not the normal plane of ABE but BCD, so BCD, okay. And we want to change the vector, so D over there, and the common letter will be B, the common point will be B, alright, and this one I want to change it by C. So take some time to make the good calculation, because it's really important for the next part, and this will not work if you don't have the same thing than me. So we set the normal vector for each plane. Now we need to set the director vector for side and base plane. So basically, again, the base plane is the pyramid one, the square base or rectangle base, depending on how you see that, and the side plane, because the side plane have always the A point common. We only need one director vector. So let's make private void set director vector, and to be able to set the director vector, what we need to do, what we need to have is to have the vector 3 and the position of the game object you want. Position object wanted. Okay. And now what we need to do, we need to make director vector side plane. So the vector director side plane will be equal to basically the position object wanted minus, so a dot transform dot position, and for the base plane, so basically this one will be equal to, again, position object wanted minus, so b dot transform dot position. Okay. Now we can save this. So now we set the normal vector and the director vector, and with these two settings, now what we can do, we can check by multiply the director vector and the normal vector the result of the scalar product of our vector. If it's positive, if everything is positive, it's meaning that the object is inside our pyramid. This is how we can determine if a point is inside the pyramid. So let's do this. So let's create a private bool is object inside camera, and we'll take in parameter a vector 3 position wanted, because we want to check position object wanted. Okay, like this. And basically, so what I will need to do, I just need to call our set normal vector for each plane. Some people maybe will tell me maybe this is not good to call each frame this calculation. It's true. I can make something like, if the position of the camera is not moving or not rotating, I return. But there's so many parameters other than the transform and the rotation from the camera. This is why I don't want to overcomplex the issue. So this is why I'm not doing, but feel free to make it. So the set normal vector for each plane will be recalculated each time. I will need to set a director vector because if I move the object, I will need to recalculate our vector director. Same as if I move or rotate our camera, I will need to recalculate the normal vector for each plane. And what I want to do, so I want to return, and I want to return something very huge. So vector 3, so vector 3 dot dot, and this is the scalar product of two vector, and this will return me a float. And I will want to make the dot for the side plane, so the side plane and all the faces, so this one. And if the scalar product of the two vector is positive, what I want to do, I want to check the other. So let's copy paste this. So 1, 2, 3, 4, 5, and ABC. So ACD, okay. ADE, like this. ABE, Okay, and the last one, BCD, and because BCD is not a side face but is a base plane, okay, I want to have this. So we can remove the last one and like this, and basically this will return me truth if all this condition is satisfied. So now we can save this, and basically all mathematical approach is done. We just need to call is inside camera to see if it's working. So if so let's just make a debug.log is inside camera, and let's call our game object, so object to check dot transform dot position. Okay, so let's save this. Now let's head back to Unity. So as you can see, the cube is over there, my main camera is over there. So now let's move a little bit my cube to see if it's inside the camera. So as you can see over there, it's inside the camera. So let's save the Unity scene and let's hit play to see how if my code is working. So as you can see, if I go on the console, true is showing, because as you can see, we can see the cube is inside our pyramid. Even if I move it, it's still true. And if I move the cube, and as soon as it will leave the field of view at the pyramid from our camera, this will turn to false. And there it is, guys. So as you can see, it's turned to false. If I head back, it will turn to true. If I move, it will turn to false. Oops. Yeah, it's turning to false. If I go down, it's turning to true. And if I come back, it's turning to false, obviously. And as you can see, so maybe let's reset his position because it's 0. So as you can see, it's false. Now let's here. So it's true. Is false, is true. So one more thing I need to tell you about this method. He got some issue because this will only check if a point is inside a camera, and the point is not part of the cube. I mean, as you can see, if I zoom on the cube, the point representing on the cube is over there. So if I let me show you with some quick example. As you can see, the camera is still seeing the cube, but if the part of the center of the cube is outside the camera, as you can see, so let's me like this. As you can see, it's turning to false because the center point of the cube is outside the pyramid. The code is working, but the render over there is still showing by the camera. So to be able to check if all the point is inside the camera, you will need to have 4 points, maybe even more, 8 points for the cube to check if all the point is inside the camera. I will not do this today. It was just a basic example to see if transform position a point of the space is inside the camera. This is working again, but be careful with that because it's not taking the render in the calculation. So that's it, guys. So I hope you enjoyed the video and I hope you learned something, and I guess I catch you guys next time. Bye bye. Thanks for watching. So if content equal to like or user learned something equal to true, user should thumb up plus subscribe. Else, user should dislike but help me to improve. Thank you, and I catch you guys next time.